Okay, we're going to use trig identities to find the value of each expression. So we need to find cosecant theta and we need to find cosine theta using trig identities. The information they give us is that sine of theta is 1/2. Well, sine is positive, and that's positive 1/2. Sine is positive here, and all trig functions are positive here. So let's see, sine is positive here and here. And this says tangent is less than 0, or tangent is negative. Well, we know tangent is positive here and here. If tangent is positive in both of those places, we automatically can rule them out because this says tangent must be negative. And then we can come back to, well, tangent is going to be negative in the other two quadrants, but quadrant 2 is where sine is positive. So I'm just going to draw the triangle, put a theta right there. All right. And we know that sine of theta is 1/2. Okay. And what's the trig identity that relates sine and cosecant? Well, cosecant of theta is equal to 1 over sine. Well, that would be 1 over 1/2. Another way to write that would be 1 over 1 over 1 over 2. Multiply top and bottom by 2. We don't want a complex fraction. So cosecant of theta is equal to 2. All right, but we also have to find cosine. Well, remember Pythagorean theorem, or the version in trig, is sine squared theta plus cosine squared theta is equal to 1. All right, so we need to get cosine theta by itself. So we're going to subtract sine squared theta from both sides, and we can fill in what we can fill in. 1 subtract, well, sine of theta is 1/2, and then we need to square that. Well, 1/2 squared, 1 squared is 1, 2 squared is 4, so 1 subtract 1/4. Well, most of you could say, well, that's 3/4. If not, turn 1 into 4 divided by 4. That's the same thing as 1. 4 over 4 subtract 1 over 4 is 3/4. So we have cosine squared theta is equal to 3/4. Well, we want to know cosine theta, so we're going to take the square root. Remember, when you take the square root, you're going to have a positive and negative version. Square root of 3 is just the square root of 3. The square root of 4 is 2. And in the second quadrant, cosine is negative. So, negative, this distance right here, is negative root 3 over 2. And we just use trig identities to figure that out. So if we come over here, we do the same thing, find secant and cosine, and the information they give us is that cotangent is positive. Well, remember, cotangent is positive here and here, because it's same as tangent. Cosine is also positive. Well, the only time that cosine and cotangent are both positive is in that first quadrant. So I'll go ahead and draw. Well, cotangent is the adjacent side over the opposite side. So here's our adjacent side. Here is our opposite side. And we could use geometry to figure out what this side would be right here. So 5 squared plus 3 squared is equal to hypotenuse squared So 25 plus 9 is equal to the hypotenuse squared. So 34 is equal to the hypotenuse squared. Take the square root. So the square root of 34 is equal to the hypotenuse. So let's see what we have. This is a square root of 34. Cotangent. And we have to find secant and cosine. Okay. So cotangent is the same as cosine over sine. And cosine is equal to adjacent, over hypotenuse. Well, the adjacent side is 5. The hypotenuse is root 34. And if you multiply top and bottom by root 34, you get 5 root 34 over 34. So that's the cosine value. Secant is just the inverse, remember? So secant theta is 1 over cosine theta. I'll just put an equal right there. So 1 over I'll leave it this way right here before we simplified. So 5 over root 34. So I'm just going to multiply top and bottom by root 34 over 5. Those cancel. Root 34 over 5. Ta-da! Secant theta is equal. And again, there would have... Nope, we're good. We're in the first quadrant, so we know that it's also going to be positive. All right, and I think we've got some other ones to do, but I think that gives you an idea, and I've got one more video for this week. All right, that's